Okay, so far in this course we have seen software engineering teams, their the way they build the systems, the org structures, the way the code is being built and managed through version controlling, and we learn some shell, and eventually we'll move towards how the ecosystem of DevOps manages overall product release at a large scale on demand, right? So, how many of you all have seen yesterday's match? Did everyone watch yesterday's match?
Yes, sir. Yes, sir.
Okay, so did you see that in Hotstar?
Yes, sir.
Yeah. So the hot was it good? So in the Hotstar, if you observe to the right top corner, they started populating number of views. Did you see that? What was the overall view count which was recorded yesterday?
More than 55 crores, something.
Yeah, 55 crores. Okay. So if you imagine, uh, 55 crore people are trying to plug in one streaming video. Okay. At a scale where your end user count is unimaginably high and growing, but the quality of your streaming output remains a constant. Did you see any change in resolution or a dip in slowness in the video streaming during the match?
No, sir.
No, right? It
Yes.
was similar to that of a satellite uh, streaming, which typically happens in your television, right? So if you know how satellite streaming happens, you can go read. It's a high frame rate response from a substation to your TV receiver. When it's live, then you can broadcast capacities like you can go to infinite scale. But what is happening with Hotstar is they're streaming on internet, okay, which is not equal to similar to that of a dedicated satellite uplink. Every channel gets a satellite uplink space. So if you're opening a news channel, or if you're opening a sports channel, or if you're opening an entertainment channel, you will get a slot in the spectrum of the band in the satellite in which it is defined for communication system, so that one to many, many to many broadcasts can be done with a higher frame rate. But what Hotstar has done is they try to achieve the similar goal using the same streaming over internet. Okay, that is mind blowing. Now, how do you think they have achieved it? They achieved it with a very serious implementation of continuous integration and continuous deployment. Okay, that's where we are heading towards. Let me explain what this continuous integration, continuous deployment. It is very difficult to realize this picture as a student unless until you join an organization. You'll not understand this at large. But I'll try to give you an example so that you can at least try to correlate what I'm actually trying to say. Okay.
Uh,
So
Hey, sir. Like,
sorry.
sir, can I say something?
Go ahead, go ahead, go ahead.
Sir, CI/CD refers to like,
Hey, your voice is
streaming
you,
services.
your your voice is breaking.
Okay, sir. Like, CI/CD refers to like something like if the development team is ready to push the code, then we will build a pipeline which can automate the testing. You write the unit test cases, and if the unit test cases fail, we will again send to development team. These kind of things.
Correct. Yeah.
So how does this refer to that streaming? That streaming is used by pub sub like
So imagine, so that's where I'm trying, that's where I'll go. I'll present an example so that you'll understand. Okay. I'm not telling that they will achieve CI/CD only for streaming, there are different teams who sit to bring that system up. So as
Okay,
an
okay,
end,
okay. Oh,
yeah,
okay, okay, okay. I
as an
understood.
end consumer, the output product you see is the streamed video on your TV or your mobile phone, right? But in the back end, there are so many things which will happen, which
Uh-huh.
will help you auto manage the
Uh-huh.
testing,
I
deployment,
understood.
integration of your product at the end goal. So that's what I'm trying to say. Okay.
Okay. I thought, sir, you pops up is the like main thing. You are like, okay, no problem, no issues, sir.
Okay. So let's look at one example. So imagine you have um, a product like, let's look at Hotstar. Okay. Okay. Hotstar has to manage the movie catalog. It should have a link to a movie database. It should have streaming service which is live or plus 20 minutes delay live. Okay, these are typical plus 100-minute delay live. These are typical bands which are available. And you have recorded streaming. Okay. And what else you have? You have different options in catalogs. You have 3-hour movie. You have a series of clips, which are typically we call it as web series, and you have documentaries. Okay, and all of these are hooked with the respective database. Let's assume this is your Hotstar ecosystem, your product. Okay. Now let's take there is one engineering team which works on maintaining a catalog. So their duty is to define the movie name properties, the linkage to the movie file, okay, and the metadata associated with the movie. If it is going to any reviewer's website or there is some statistics associated with movie, how many people are watching, how many people halted at particular space, what is the most frequent watched clip or part of the entire video, all those stats they'll maintain. Let's assume this is one engineering team who does that. Okay. And there is another engineering team who takes care of movie files in all formats in 1080i or HD, HDD or any other quality, and they'll ensure that it is linked with this catalog. Okay. Now let's assume these people deliver files in form of HTML, JS, PY, and some SQL or database files. Let's assume their repo contains all these files. Okay. And imagine these people also have some web data files of HTML, JS, PY, any files related to SQL, or there could be any movie related files on .abi or .hdd, etc., etc. Now the point is, if you who should use CI/CD is the question. Okay, CI/CD should be adopted by companies who want to release a product in a systematic form without bringing the end product down and ensuring that the consumers are not hindered by the changes made by the product or introduction of new features. So if a new movie comes into Hotstar, the metadata will change. There will be a movie name, movie stats getting added, the movie clip will add it. If the frequency of these changes are like in hourly basis or monthly basis or yearly basis or like weekly basis, it should not hinder the performance or the existing feature which is already delivered to the end users. Okay. Now let's call this team as engineering A. Let's call this team as engineering B. So let's remember both these teams. Okay? Engineering A will takes care of catalog. Engineering B typically takes care of hosting the movie club. Now, imagine engineering A does the commit and engineering B also does the commit in their main SVN. Now this, whatever files which are bundled together from the team A, from the team B, let us call them as bundle 1. Okay. So using this bundle 1, there are tools which will help you perform this task. I'll give you one example called Jenkins. Okay. What they do is when you bundle them together, if you have to host them locally, you will just host it in localhost, but you have to host it on a live application. Your Hotstar is live being used by end users, but you are trying to deploy the changes under the sheet without making them notice. Okay, so if you have to achieve such a level of updation or changes to your end product without even hindering their performance or usage towards your product, you have to use CI/CD approach. Okay, CI. What is CI mean? Continuous integration. What is continuous integration? When people like engineering team A and engineering team create bundles, you should have an ability to generate respective builds. Okay, what are builds? Builds are bunch of bundles which are tagged with a particular release version so that you know what changes you have introduced in that build. It's like copy of your production file which is ready for deployment. Okay. Now there are tools like Jenkins which where you can programmatically define how soon I can, with what frequency I can generate builds. Okay. So typically there will be an engineering PMO, program management office team, who gives you a calendar. If you remember in last classes, we have seen release calendars where the engineering PMO tells you that if you have to release certain feature, release it in version 1, 2, 3, which is going to come in one quarter, second quarter, third quarter. The same team gives you a typical build version dates. Okay, they will give you the versions. If you remember, I've shown you example of SQL Server where they have a service pack and cumulative pack, right? Similarly, every build has those version numbers. Let's assume the version number is 10.7. Cumulative updated 10.7.1, 10.7.2, 10.7.3, and then other build is 10.8. Okay. So this 10.7, let's assume this was out in January first week. And in the entire Jan week 2, week 3, week 4, you have 1, 2, 3, 3 builds. These 3 builds are generated because engineering team A did some changes to their files, or engineering team B might have changed their files. Okay. Whenever they change their bundle files, a new build will be generated. Okay. So similarly, let's assume we'll stick to 10.8. Let's assume this was generated on February first week. Okay. So when this build got generated using a tool like Jenkins, where you can programmatically tell if there are certain changes which are bundled into an SVN, a cutoff date like Friday night or Thursday night or Sunday night, builds like this will be generated. Okay. So that the next week, people who pick those builds for testing can eventually use those builds. Okay. So 10.18, let's assume this was generated in Feb 1st. The testing team will deploy it on testing VMs and perform the tests. Okay. If they find any defects, they will log the defects on 10.8 bundle and raise tickets to the engineering team. If the bugs are related to team A, the tickets are raised to on team A. If the bugs are found to be on team B, they'll raise tickets on team B. Okay. Now assume that the team A fixed it in a week, and assume team B also fixed it in a week. A new bundle will be generated. That will be 10.8.1. Okay. So there will be typically a strict calendar where the teams generate bundles and builds. The test team picks up those bundles, performs the tests, and raises the bugs with the team. And those respective engineering teams again fix them and create bundles and give it for testing. Okay. So this iteration of testing, if you recall our test-driven development from the last class, in CI continuous integration also there they use test-driven development, where the origin of new stories, origin of the bugs come from the testing team, and the major changes they suggest will actually improve the build quality. So the latest bundle, which is tested and released, will have highly fixed bugs or less, maybe less bug free, high quality compared to 10.7. Okay. Once they sign off, they do this test based driven development in either one or two iterations. And if they satisfied with their benchmarks of testing, like it has to run as per the standard benchmarks, then they will release the final bundle, which is tested bundle. Okay, they typically name like this. So if it is in dev, they name it as underscore D. If it is tested, underscore T. In some companies, they will call it as alpha release and they call this as beta release. Okay. In companies, they call it as underscore U, underscore I. U is like for used, I is for initiated for release. Okay. So people use different conventions. So when someone is trying to build something, if they adopt a CI approach, continuous integration, there will be a strict frequency of build generation, like weekly basis. Those builds are tested by respective teams. They come back to engineering in the form of defects, and the builds will again be generated. And once the test team gives a sign off, there will be a final beta build will be generated. Okay. This beta build, reaching the beta build is the goal of continuous integration. Why? Because I have shown an example of two teams. Imagine if there are 50 engineering teams. 50 engineering teams does the changes as per the weekly build generation calendar. The test driven development, the testing team should eventually have to raise back those defects with all 50 teams. They have to again check in their changes, create builds on weekly basis, and generate a alpha and generate a beta build. Okay. So in this, if you look at the scale of the engineering teams, if the number of teams grow, the effort or stress on testing team will also raise. Okay. So if with two teams there's only one build, for 50 teams there could be too many builds. So to avoid that, what typically the testing team does is they will break this process into sub processes. Like what they do is they will ensure that team A, B, C, D, let's assume you have 6 teams. Okay, E, F. Builds are usually generated based on the dependencies. Okay, imagine there is a dependency between team A, C, and D. Okay, there will be a alpha build first generated for the QA team to test. And if B and E and F can independently go for testing, this build is generated separately. But when a final QA is done, the build of A, B, C, D, E, F is launched together, and then a testing is done on another version of alpha. So they call this as alpha 1, alpha level 1. This they call it alpha level 2. They perform the tests, the testing team perform the test on the alpha 2 build, which is the combination of two different dependent code bases, and eventually give you one final beta build. Okay. Okay. So at this level, when QA team performs the testing, they do typical unit performance testing, penetration, all types of those testing. But when QA team perform testing here, they majorly perform integration testing. Okay. Where they'll see if the dependencies are still holding good when the non-dependent products are merged together. Are they able to switch from one module to another module? Is the data flow, control flow working as per expected? Those aspects are tested at the alpha 2 level. Okay. And then the final beta build will be generated. So this brings the closure towards a continuous integration. So if you scale the number of teams from 6 to 50, 50 to 100, 100 to 200, the number of level alpha 1 builds will also grow, and they eventually come up with the final alpha 2 build. Okay. So that the integration testing can be done and then the beta build can be generated. Okay. So with continuous integration, you will no longer be in a dissolution state where what team A is doing, what team B is doing, what team C is doing, what happens when these two files from these two teams are merged together. Can that be testable? So before before continuous integration was not introduced, the build generation was in chaos. It was very difficult for people to do integration testing because most of us manual. But tools like, there are tools like Jenkins, which we use a lot at our end. In my career, I used it a lot. This tool helps you to define this workflow. Who is the team A? What is their SVN? Who is the team B? What is their SVN? When you do Git operations, it will review the conflicts, it will review the merge issues, and eventually creates these alphabets. And when you can also, when these people are done with the QA and alphabets, when they allow or enable the pipeline in Jenkins to create alpha 2 build, the SVN will automatically pick up the repos and merge them together so that the alpha 2 build can be generated and the QA can perform the integration testing. So you can now programmatically perform these tasks uh, with n number of teams with n different variants of builds in one place. Okay. So when you join an organization tomorrow, if you're sitting in one specific team, which either works on API or web development or backend, or they may be writing an ML algorithm, or they may be writing a data engineering project or data pipeline. The idea is all the teams should follow a similar build generation calendar. If there is a fix coming, they have to abide by that build. They have to abide by the QA results, and they should also follow the calendar of fixing those bugs in those turnaround time. That's why, you might have seen most of the software engineering teams stressed when they are heading towards a release, right? The reason is whatever the quick fixes or bugs which break the system while generating the integration build will make the engineering team work on them quickly, because you will have a calendar where you have to deploy a beta release on time. Okay. If the respective engineering teams couldn't fix those fixes, let's assume there is a page written by team B and one of the JavaScript there is a bug and they couldn't fix it. What they do is, while generating the beta build, they will just remove the enhanced version of that JS and keep that beta build bug free. Okay. So with continuous integration, you have that benefit. If the effort of fixing the bug which was observed either in alpha A level, alpha 2 level, and if it requires a complete revamp, Then they'll just skip those files and then include the rest of the files which are working as part of integration testing, and they generate a beta build. So when they generate a beta build, it is now production ready for deployment for customer or end user to consume. Okay. Any questions so far until continuous integration? Okay. One important thing you should remember when you join your organizations in future is the turnaround time of giving a fix, delivering a feature change, and committing your code into your main repository goes through a laborious process and multiple middlemen. Those people typically do. So if you're writing a code in HTML and JS, and if you are in the CI process, continuous integration, there will be a code reviewer who will review the standard of your code and approve it for checking, approve it for committing into your SVM. Imagine if your code review also fails, your change will not go into that alpha release. Okay. So the idea is, as a developer, you should ensure that you follow all your standard organization guidelines to perform your changes in the ticket or the bug which is given to you, so that it passes your code review, passes your unit tests, and then allowed for committing into the SVM. Okay. In typical large companies, most of these parts, like alpha builds, are automatically tested using test case automated testing tools. In next class, we will see what those tools, what type of automation testing can be done in case of these alpha builds. But they will try to avoid as much as human intervention in this piece. There will be very less manual testing done in these alpha 1 builds. But in case of alpha 2 builds where integration is required, there you have automation, but in some companies, most of the time they perform the manual testing just to see if it is providing a similar experience like how the end users are expected to work. Okay. So this is a typical continuous integration. Now, any questions so far? Yes, no?
Hello, sir.
Yeah.
Sir, like what is this software build and some like what is this
I didn't
build
get you,
version?
but
What is this soft? Sir, I was asking about what is this software build and what build version, and I couldn't get those things.
okay. Okay, so what you're seeing on my screen is the Angular JS framework. Okay, so these are the people who actually contributed towards building Angular JS. So this is the engineering team. There are 43 members. So if you look at, there is one public repository which is like a final post beta release. Okay, this is a JS framework. This is a component framework, and this is a command line interface framework for Angular. Okay. Now, if these 43 people wants to add any new feature, what they do is they will copy the entire source code, okay, and create a clone of it. Okay. On that clone, they perform changes, and when they perform those changes, they generate a build like this, which is a cloned copy where the changes are present. Okay. Now, when the QA tests those changes, they'll not pick the primary repository. They pick the repository of these build, which is nothing but the same repo where the fixes are present. If you look at the notes, they'll write notes like this. See, see what are the changes they have introduced. They didn't write any notes. Let's look at this. Okay, he didn't write, so he just wrote update Angular. Ideally, they'll write notes on what changes they have done. So if you observe, they're actually trying to zip the same code, perform those changes, and check in back into the respective build. So if you go to Angular, you'll see multiple builds which are nothing but copies of changes performed by respective dev team. So there is a build generated on Sunday. So for entire Angular, there is a team which works on semantics, and there's a team which works on ng tools, dev kit. So at the cutoff of Sunday night, all the builds got generated. Okay, and only few has the changes. So if you look at this Angular example itself, there will be one master repo where you have all file structures in your Git or a Bitbucket or your any Gerrit or any version control tool. Developer one takes a copy of this repo, makes some changes and creates a copy and gives it to the DevOps team. DevOps team creates a build on top of it, which is nothing but the changes made by this person, okay, and contains all the files from the Angular and also the changes this guy done, and they call it as one build. Okay, because I've given one person example, if there are 10 people working on the same repository, all those changes are merged into this cloned repo, and a build will be generated where all the changes of those people are present. Okay, now what I'm trying to refer over here, alpha or beta builds are nothing but these builds. Okay, so when someone is making changes, they will be given time that every Friday, whatever change you're making, every Friday do it before 5 p.m. so that after 5 p.m. all the changes you push into your working directory. If you remember from your Git session, there is a local repository, working directory, and the remote repository, right? So whatever changes you are doing in your working directory in your local machine should be moved to your local repo. From the local repo, whatever files are moved in local repo will be pulled into the remote repo. So remote repository is nothing but your build, where it is deployable for QA team to test. Okay. Did I answer your question?
Yes, sir. Yes, sir. Like it is the merged form of the old code and the new code.
Correct, correct. Absolutely, absolutely. So now, yeah. Any question?
No, no, sir.
Okay. Yeah. So now if you look at continuous integration, what continuous integration is helping you do is, irrespective of the change you perform, if you do it or not do it, there will be a fixed calendar where the builds are generated on week or month on month basis for QA team to test and release the beta version of that product. Okay. Now the biggest question is, I'm having the engineering team work and systematically and generate beta builds. How do I deploy these changes on demand without hindering the performance of the end user, or without letting them know that there is a deployment happening in the backend while they enjoy or use the product? Okay, that is typically achieved by what we call continuous delivery. Okay, so CI/CD is the input. CI is input to CD to perform the deployment. Okay, in the past, when CI/CD was not practiced, how people used to deploy products is, they will bring down the system down. They show notice page to people that there is a software update going on. Please come back after a day. And then once the software is up, people are allowed to access the website or the product. That's how the conventional deployments used to happen. So in conventional deployments, what they do is, they will remove all the files from the application server, get the new files inserted into that application server, and then verify all the connections and do some sanity testing. Sanity testing is to check whether everything is running, and they remove the maintenance page. Once the maintenance page is gone, the site will be usually up. So if you speak to your parents who used to use banking websites in the past, or if they used to use broking websites like stock market broking, there used to be maintenance pages during Saturday, Sunday, or during 31st of every month, where all these deployments usually take place. Okay. But today that is not the case. The deployment can happen anytime in a day. The deployment can happen when the match is live. The deployment can happen when huge banking transactions are happening on front end. That's all possible using what we call continuous deployment. Okay. Now, what does continuous deployment do? The input to the continuous deployment is one build, which is production ready. Okay. This build is nothing but bunch of your repo files will be typically sent to a review module. Okay. This review module will verify whether the source code is similar and dissimilar compared to what is there in production. So imagine you have certain folder directory in your production, which is actively accessed by end users. It performs the diff and checks what is the percentage of change. Okay. Now, in your tools like Jenkins or any other, I think there's a tool called Basil. Some people write their own in-house tools for doing CI/CD. You can define a criteria that if the change percentage is 10%, then only perform the deployment. Or if the change percent is more than 15%, don't deploy on any day, deploy only on Friday or Saturday. If my changes are around 25% or to 30%, then do not deploy on any working day. Primarily deploy them during non-production hours. Non-production hours are the hours where the usage will dip. For example, for India, non-production hours are typically after 8 p.m. or 10 p.m., where people go to sleep and they don't use the application much. In USA, it is typically after 5 p.m. or 6 p.m., where people don't use the typical business applications, okay, like banking or etc. So if the changes are huge, then they will prefer to deploy the product during non-production hours or during weekend, or if the changes are very small, they happen in any part of the day. Okay. So when let's assume the changes are small, and today 8 a.m. there is a build tool which picked up the build. Okay, let's do a very good example. So Monday, let's assume there's a developer who worked on the fix, and on Saturday, Saturday 5 p.m. he has submitted the code into local repository. The tool like Jenkins has generated build by pushing the code into remote repository, and let's assume the build is ready. Now this is CI process. In CD process, Saturday evening after 5 p.m. the CD will look at the review of this build. Okay. It does the review of the build. If the build is like 5% change only or 1% change, based on that review, it will deploy the code in an environment called staging. Okay. Staging is like a replica of a prod where it is not exposed to end users. It is a playground where you deploy your production ready code and give it to bunch of beta users. Beta users are the test users, which are typically bots today, or people who manually go and run the UI and check everything is fine. Okay. This is typically taken care by QA team, or there are roles like site reliability engineers. We'll go there about what site reliability engineer does. We have one class where we talk about a daily life of DevOps engineer and site reliability engineer, etc. There I'll explain who this fellow is. But in general, the QA, site reliability people and the DevOps resources deploy the product in stage and perform basic testing, okay, to see everything is up. Once the changes which are brought in from the 5 p.m. when the review step is completed, okay, and the staging is completed, then the code is replaced in production without bringing the entire product down. Okay, how do they do that? So in continuous delivery, let's assume this is your build, review has happened, it got deployed on staging, and then on production. Okay, imagine in the build there's a change in the logo. Review figured out that this is like 0.01% of change. In staging, the logo PNG file was replaced and the new logo was present, right? In production, when they perform the deployment, they will not deploy the production file automatically. I mean, they'll not deploy the file by replacing the image in the local directory or something like that. What they do it, they typically do it in phases. Typical production website, if you take SaaS products, they are hosted in different parts of the world. So for example, if you are in Europe, okay, you will have one hosting server where your files are present. If you're in South America, your server has an hosting files, okay. If you are in Asia Pacific, you have a server where you have files where all the people will hit this traffic, right? If you are in US or North America, your server structure is like this. What they do is they will create a copy of your product, apply the changes, bring this up and bring this down. Okay. So I'll show you another example for North America. Imagine 100 people are connected to this website. They will create a copy of this, apply the changes, bring this the existing site which is accessed by people into bring this down and bring this instance up. How do they do it? They do it using something called load balancer. In load balancer is a software. Typically, it's like a layer in before your website and your actual product layer or API layer, where it helps you manage the traffic, okay, traffic of your users. So imagine if you have 3 machines where you have having a copy of your product, multiple people who are accessing this website are divided into 33%, 33%, 33%, so that your product is up. Okay. When you're doing production deployment using continuous delivery, what they do is they will remove server C from this load balancer, make the changes to server C, and then bring the server C up. And after server C is up, they'll bring server B out of this load balancer, perform the production changes, and then bring this B up. And in the end, they'll bring the A offline from this ABC, deploy the changes, and bring the A up. So by bringing server A, B, C, or D out of rotation one after the other, they will eventually ensure that your production deployment is seamless. Okay, they'll actually divert the traffic from the server which is being brought out of rotation to the servers where it is capable of handling the throttle. Okay, so this way every region you can perform an automated deployment by bringing the server out of rotation, deploying the code on it, and bringing that server back into the load balancing. Okay, so this is what happens in SaaS products. Most of the web products, most of the SaaS products follow a similar mode of setting up your environment. Okay, so in case of continuous delivery, where we have looked at the logo file, if the change is very low and if it passes in stage, by bringing one machine up, down, out of rotation, they will perform a seamless deployment without bringing the entire system down and throwing a notice page. Okay, like they not show any maintenance page. As you refresh the file or as you refresh your web page, the change which is there in the web server will be updated onto your end user console. Okay, in some cases, there will be a end user browser cache. You will have an ability to flush that cache through the load balancer. You can push the end user refresh so that they will get the latest source code changes on the web whenever they want to see the end product. This is typically for the web. But if you are looking at a middleware layer and a database layer, they also happen in a similar form, but they are not managed using load balancer. They are typically performed by setting up a parallel infra. For example, there is a column addition in your database and you want to release it as part of your continuous delivery. And this is your web on node A, node B, node C, your load balancer. And here you have a middleware where you have your web services and there is database. Okay. Now imagine your build has a change in the table and column definition. Okay. They'll not look at the load balancing itself. They'll not bring any server rotation down. They will try to create a copy of this database, perform the change. When the change is done, they will update this connection string so that when they switch this connection string, seamlessly whatever request which used to be addressed to this machine now will be routed to this database. Okay, so this is how a front end level CD will be done and the back end level CD will be done. Okay, so typically if you look at an end-to-end pipeline, once again as an example, you have different engineering teams who typically build products in silos, and there will be a build generated on weekly basis. This build is typically, we call it as alpha build. It is tested by QA team. Any bugs that are present in this will be eventually should be addressed by engineering, and in the end the final beta build is created. Okay, this is where the continuous integration stops. This will become the input to the continuous deployment. Now in case of deployment, there will be a review step where it will check what is the rate of change of the code. Based on the rate of change, you can automate. If I have to deploy on demand, or should I deploy during weekends or during non-production? And after the review is done, it goes to staging. If everything passes in staging, it goes to production. Okay. Any questions so far? So let's look at an aspect of security in CI/CD. Okay. If you look at the entire pipeline as an example, in case of continuous integration, okay, you will have a typical build here where it will be the engineering teams are custodian, but when they perform the builds, there are tools like Jenkins. I remember using JUnit, which is for unit testing. There is something called Sonar Cube, which is also a test case suite, which will help you do unit testing. Okay. Once you perform and generate build, there are other tools which will take care of security. I mean, who should have access to which part of build while deployment is happening. Okay. There are tools like again JUnit can help in some form. Very interesting tool which I have seen is JMeter, Apache JMeter, which will help you do the continuous security. Okay, and when to deploy, I mean to review and to deploy, the most widely used tool for web is Amazon Web Services, where the changes which are brought in by SVN, all you have to do is fill one form in Amazon Web Services. They will take care of the auto deployment by bringing server out of rotation, merging the traffic, and then bringing one server up. There is open source tool, I mean not open source, but widely used tool is called Octopus. Okay, Octopus Deploy, which is a very good tool for people to um, manage the data pipelines or ETL jobs. Or I've seen some examples where they were doing for mobile apps. So Octopus Deploy is a very good tool. And in the end, if you have to figure out whether all these changes are really working or not, you need tools for monitoring. Okay, monitoring and what people call observability. Monitoring and observability helps us to check whether the server which was brought up for end users is the traffic being diverted correctly. Are they getting any 500 errors? Are all the requests 200, which is nothing but success? Those things are typically viewed in tools like New Relic. Okay, and there is a tool called Grafana, which is a very simple tool where you can look at how things are panning out. Okay, are people using the website properly? Is the data being read properly from the backend? Is the DB down? Is the DB up? What rate of DB is up? Where the CPU consumption is high? All those things are typically taken care while working on the monitoring and observing. So these are the typical tools people use: Jenkins, JUnit, SonarQube for generating build, test, unit tests, and automated testing. JUnit, JMeter for typical continuous security and continuous deployment and integration. And then for observability, tools like Grafana, New Relic are typically used. Okay. Any questions so far? Okay. That's all I have for today. Tomorrow we'll look at the automation strategies. What automations can be done at a web level, at a web services layer level, at a API level, at a database level, in the perspective of testing and development, so that you can get an opportunity to think how CI/CD and automation can be merged together. Okay, great. Thank you and have a great day. Bye.
Thank you, sir.